Welcome back, everyone. Congratulations on making it through Unit 1. Take a moment to be proud of yourself for your accomplishment. All right, that's long enough. We need to get moving right into Unit 2. Unit 2.1 is Objects, Instances of Classes. So we're going to learn about classes and objects. Our learning objective is to explain the relationship between a class and an object. So I want you to bring me an object. Go ahead, bring me any object. Just set it right in front of the monitor. I'll see it. All right. I see that some of you put a phone down in front of your monitor. I don't know why we have our phone out when we should be learning computer science. Some of you put down a pretzel. I see we're having a snack while we learn. And some of you put down a pencil, which means that you are likely taking notes. So, congratulations. So now I have a large collection of phones, pretzels, and pencils. Now, when we have an object like a phone, we expect a phone to look a certain way. And then we also expect a phone to do certain things. Same thing with our pretzel. When we say pretzel, we expect that pretzel to look a certain way and we expect it to do certain things. And same thing with any objects. So if we are looking at the phones and those phones that you gave me, looks like you all are in need of an upgrade. But in order to classify something as a phone, we expect it to have a screen, some buttons, a port that we can plug into, and a case color. So if your friend tries to tell you they got one of those fancy new phones without a screen, you'll be like, did you really get a phone? Because I expect a phone to have a screen. And then we expect our phone to be able to do certain things. No matter what the phone looks like, we expect it to be able to make phone calls, to text, use apps, and take pictures. And so when we get an object that looks a certain way but doesn't do what we expect, then we get confused. So if we have a cake that looks like a phone, we would get confused because we can't text on it. Or if we get a pencil that looks like a pretzel, we would probably be pretty upset if we tried to eat it. So a class is kind of like a blueprint. It defines those attributes and the behaviors of the object. So we could have a class that's a phone, and then we can have some objects from this class. We might have an object like an iPhone, an object of a Galaxy phone, or an object of a Pixel phone. But they all belong to the same class called phone. So the object is an instance of that class with defined attributes. So when you get your iPhone might have a different case color than somebody else's iPhone. You might have a different amount of storage on your phone than somebody else. But at the heart of it, it is still a phone. It will still do the same thing as somebody else's phone. This is the idea of object-oriented programming, the ability to create many objects from one class. This lines up with our essential knowledge. An object is a specific instance of a class with defined attributes. So we are going to learn the proper way to speak about the relationship between an object and a class. We can say an object is an instance of a class. An instance is just a single occurrence of something. So an object is just one single example from a class. Or we can say an instance of a class is an object. It's two ways to say the same thing. So looking at the first one, an object is an instance of a class, we can say a Sherlock Holmes object is an instance of the detective class. So again, detective, that class is a blueprint. You can make many different detectives from that, and we are making one specific detective object called Sherlock Holmes. A different way to say a similar thing, an instance of the board game class is Monopoly. Board game is the class, and Monopoly is the specific instance or the object that we made from that class. So we're going to look at those sentences in each of the different ways. In this first one, we want to know what could be an instance from these different classes. So look at these classes and see what kind of object you would make from this class. If we had a book class, we could make a Hunger Games object. Yep, I picked Hunger Games. District 11 represent. If we had a Ford class, we could make a Mustang object. And if we had a video game class, we could make a Pac-Man object. Looking at that sentence a little differently, now we have the object and we need to decide what overarching class it belongs to. So a Spider-Man object could be an instance of a hero class. A sandwich object could be an instance of a lunch class. And a Squirtle object could be an instance of a Pokemon class. Our next concept is about attributes and behaviors, and where we're working on that same learning objective, explain the relationship between a class and an object. So we've all been there. It's bedtime. We don't want to go to bed because we might be scared of the monster in the closet. Now, we all might have different monsters. My monster might be blue and fuzzy, while your monster might be a zombie. Somebody else's monster might be a cosmic horror, or a giant lizard, or a vampire. But whenever we tell somebody we are afraid of a monster, people expect monsters to look a certain way, and we expect monsters to do certain things. So if we look at one specific instance of a monster, we expect it to have some attributes. Those are the properties or characteristics of the object that defines how that monster looks. We also expect it to have some behaviors, an ability of an object. That is what that monster does. So in programming, attributes are variables. It would define things like number of eyes, which would be an integer, or skin type, or teeth type, or height. And every monster would define its own attributes. Every monster could have a different number of eyes, a different skin type, different teeth type, and different height. Now, the behaviors would be methods in code that defines what monsters do. And while monsters can have their own individual attributes, all the monsters share the same behaviors. Every monster should be able to jump out at you and scare you and chase you. So, going back to our previous concept, a class is like a blueprint of an object. It lists the attributes that an object can have, but it does not set them to any specific value, and it defines the behaviors that an object can perform. So, we can have a class that's a monster. For something to be a monster, it would need to have some attributes and it would need to be able to perform some behaviors. The class just defines that. It doesn't set any of those to any specific values. It's once you start to make objects is when you get to then define those values. So you can make your own object, give it a name, call it my pet monster, and then you can define the attributes. You could decide how many eyes it has. You could say it has 2 eyes. Its skin type is fuzzy, the shape of its teeth is sharp, and the height is 2 feet. And for it to be a monster, it needs to have all of those behaviors. So you should be able to tell your object to use one of those behaviors. You should be able to tell it to use devour, and then it would perform that action. So the class is the blueprint. It lists the attributes and defines the behaviors, but then the object actually sets those attributes to a value and then can actually perform those behaviors. And you can make many objects from the same class. So you can make your own monster object, just give it a name and define its attributes. So looking at an example in Java, we want to look at that class on the right. So we are defining a class and we are calling it monster. And we said attributes are variable. So we have those attributes listed at the top. We have an int number of eyes, string for skin type, string for shape of teeth, and int for height. Notice it doesn't set any of those to any particular value. It is just listing the attributes that a monster will have. Then we have some methods. Methods are the behaviors. So we have our chase method and we have our devour method. And every monster will have access to those methods. Every monster will be able to do those things. So on our left, you can see in code, we created a monster called my pet monster. And then we are setting those attributes, those member variables to specific values. And then once we have that monster, then we are calling a method to tell it to do something. This aligns with our essential knowledge. A class is the formal implementation or blueprint of the attributes and behaviors of an object. So starting with attributes, an attribute of a car class could be speed. Every car has its own individual speed. Not every car has to travel at the same speed all the time. Every car item that we make from the car class will have its own speed. An attribute of the hero class could be health points. So every hero has a different amount of health points. An attribute of the Pokemon class could be type. And we all know that dark type is the best type of Pokemon. No, I'm just saying that because I know some people just got really mad at their computers right now because I said that. They're like, no, fire type's the best. Looking at some behaviors now, behaviors are the ability of those objects. So if we make an item from the car class, what should it be able to do? Well, a behavior of a car class could be accelerate. A behavior of a hero class could be talk it out. I know some of you might have thought, hey, a hero could fight, but really, I think a real hero talks out their problems. And a behavior of a Pokemon class could be use held item. That's going to do it for this lesson. Make sure you rate how you feel about the learning objective. Hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video, and keep programming.